Hi there everybody, today we're going to look at plotting quadratic graphs. That's a bit of a mouthful. Reasonably straightforward, very similar to plotting linear graphs, but of course how it looks will be a little bit different. And then the second half of the lesson we are literally going to look at what else you might be able to do once you've plotted quadratic graphs and how that could potentially help you solve simultaneous graphs on the same Cartesian basically grid. Okay, well let's dig into it to start with, and let's have a look at how we plot a quadratic to start with. So if you're asked to plot a y equals x squared plus x minus 4, there's two ways we can do this, and the most normal route that I think most people would go with is we're going to basically try and plot a bunch of coordinates. All right, so like we did with linear graphs in terms of plotting a linear graph, we could do with a table of values to put in, and sometimes you're given a table of values, it's likely that you're going to get a table of values to draw a quadratic graph, but in this case sometimes you might have to kind of decide which ones to use. All right, so create a table of values. So we've got a bunch of x's, and therefore going to give us a bunch of y's. So putting a number, a good set of numbers in here, right? The whole reason you've got a good set of numbers is probably because this is not a linear graph, it is not straight. All right, it will take a parabola shape, which is like a big U, effectively, if it's a positive x squared, which it is. So we're going to try and put these numbers into it, and of course we've got to be very careful. We'll probably should be okay with the 0, 1, 2, 3, 4 because these are positives, but what we've got to watch out for is the ones where it's negative. All right, because we're going to square a negative and then we're going to have a negative here, and when we do that, we've got to just be careful that we don't make mistakes when we're squaring a negative, because obviously a negative now times a negative is a positive, so that will kind of change. And that will remain the same when it stays a negative. All right, so let's go through one by one. All right, so when I put x equals minus 3 into it, you'll see that what I put is minus 3 in a bracket squared. All right, and the reason for that is so that our calculator doesn't make a mistake on it, because if you don't put the minus 3 in a bracket in a calculator, it just does 3 squared and shoves a minus in front. All right, what we are doing is doing minus 3 times minus 3. All right, so the bracket matters. And then we're going to add the minus 3 and then take away another 4. All right, and that's going to give us 2, and that's going to go in our table. Oops, sorry about that one. The 2 into here. Okay, then we're going to repeat the process for minus 2, and you'll see the same process being done. And they're going to give us a minus 2. And we're going to speed through this next little bit because you see it's very much the same for all of these. I'm going to put minus 1 into it. That's going to give me minus 4. I'm going to put 0 into it. And it's going to give me minus 4. Put 1 into it. And put 2 into it. And put 3 into it, and so on and so on and so on. So I'm sorry if I'm kind of rushing through it a little bit, but you can see from there that they're all kind of going in. All right, so that gives me a set of coordinates. So here I've got minus 3, 2 is going to be a coordinate which I'm going to plot. So minus 3, 2 is going to go just roughly there. All right, they're going to do the same for the next one. So minus 2, minus 2. So minus 2, minus 2 is going to be there. And then minus 1, minus 4, so minus 1, minus 4 is going to go there, and then 0, minus 4 is going to go there, and then 1, minus 2 I think is going to go there, and 2, 2 is going to go there, and then 3, 8 is going to go up there. All right, and what you should see is you've got this, what we call this parabola shape taking place. All right, so join the points with a smooth curve, you can see what's happening. All right, you probably would guess if you had minus 4 in there, it would probably go to 8. All right, and what you'll see is it's a symmetrical graph. If I put a line down the middle here, which looks like it'll go through a half, then you'll get something which is basically a line of reflection. Okay, so it's a symmetrical parabola is what you should end up with. All right. Now, if you don't get something that looks like that when you're plotting quadratic graphs, then somewhere in here, when you've been doing your calculations, something's gone wrong. All right, it must take that shape. It should be nice, smooth, parabola type of shape. That's what you are expecting to see. All right, so please don't do anything different. Please don't think that maybe it doesn't take that shape. It does, and it needs to. All right, so that's essentially how to plot a quadratic graph, but you may be asked to find a solution from a quadratic graph. All right, so I'm just going to talk to you about those, because once you've plotted a graph, so here you see a graph of y equals x squared plus 2x minus 3, it might ask you to estimate the solution of x squared plus 2x minus 3 equals 0. All right, so what this is what's changed is that this here, you can see the y has become 0. All right, your y has become 0. That means your height is 0. So when is my height 0 on this particular graph? Well, it's when it crosses the x-axis. So these two values here, all right? And the reason is actually to estimate it, because we haven't calculated it, we're just doing it from the graph. So I've got a value here and a value here, all right? So my x value is going to be 1 and minus 3, all right? Now, if I factorize this, you'll find that it's exactly what you're going to get. You're going to get these two numbers kind of coming from it. But we're not, because we're using a graph, and it's asked you to use the graph. So that's exactly what we're going to do. So these two numbers here are going to be my two solutions, okay? So you can see my line drawn there where my y value, my height, is 0, and those two numbers, which I've just kind of mentioned, are going to be my two solutions to that specific question. So x squared plus 2x minus 3, okay? Where it crosses the x-axis, these are sometimes called the roots, all right? So if you're asked to find the roots of a quadratic, so you have to find the roots of this, and then it's going to be these two numbers that you just worked out where it equals 0, okay? Right, you can see that written at the bottom. Right, what happens if it's not 0? What happens if the number is a 2? Well, again, same kind of process. I'm still trying to estimate it. I'm still trying to figure out what those numbers are. So what I'm going to do in this case, so rather than it being y is equal to 0, I'm going to draw a line which is y is equal to 2, which is 2 up higher. So if I draw that there, you can see it. And then I'm going to estimate what I think that value is there and what value that is there. Well, that looks to me around about minus 3.5, and that one looks like 1.5, give or take. All right, so minus 3.5 and 1.5. And normally, because it is a sketch and because it's a graph and it's probably something you plotted, obviously you want to try and do it as accurate as possible, but there's going to be some kind of slight variation in terms of the answer that is accepted in the exam, because they appreciate that whilst you're obviously trying to do it accurately, there may be some slight discrepancy. So try and be as accurate as you can, but there will be some kind of range involved in there. All right. So that's that one. And then what happens if it's x squared plus 2x minus 3 equals minus 1? Well, minus 1 is the bit that's changed this time. So like I've done for the previous two, I need to see where the line y equals minus 1 is, which goes right across the middle there. So I'm looking at these two values, and you can see from this one, this is definitely not minus 2.5. That should be there. And a half, which is going to be there. There's definitely further up than that, and I reckon it's probably around about 0.7 and maybe minus 2.8, all right, or something to that effect. That's where I'm going to go for. It looks like it to me, but let's see what they put. So minus 2.7, oh, there you go, minus 2.7, I thought maybe 2.8, minus 2.7, and then the other side, 0.7 over there, all right. That makes sense. All right, so again, it is a rough guide. We're not perfect. Well, we might be perfect, but I'm not entirely sure. I'll have to double kind of check it, but we are looking just as an estimate, and we're using our graph to guide it. So as long as you're clear and you can show it, there's no reason why you shouldn't get the marks, okay? All right, so we looked at a quadratic graph, plotting it, and we looked at potentially finding solutions from it. The last little part of this is potentially if you're having to solve two simultaneous equations. That means two graphs, or two graphs on the same chart. All right, so to estimate a solution to a quadratic simultaneous equation graphically, that's the key thing, you need to plot them both and to see where they cross. All right, so we're not doing it algebraically, we're doing it graphically. So here are two equations. So you've got y equals x squared minus 2 and y equals minus x minus 1. So what you would need to do, you would need to draw those two graphs separately on the same axes, and then try and identify where they cross. All right. Well, I'm not going to go through the process of plotting both of these two, but I can tell you that, like before, what you're looking to do is maybe a table of values for this one, maybe a table of values for this one. There are quicker ways of doing it, especially this one. But with this one, you know, you're probably going to have to put some numbers in there to see what it looks like. All right. But when I put them on there, these are what they look like. So you can see you've got x squared minus 2, again taking that parabola shape which I've mentioned before, and then the other one, which is a straight line because there's no x squared involved, it's minus x minus 1, so it's got a negative gradient and it crosses at minus 1, so it looks exactly like that. All right. So to solve them simultaneously, so when I'm solving a simultaneous equation, I am looking for an x and a y value. Well, I'm going to have two coordinates here. So two solutions to this. So an x and a y for this one, where they cross here, and an x and a y where they cross here. All right. And again, it is an estimate. All right. We're not doing it properly. We're not doing it algebraically. we are doing it by using our graph. Okay, so estimating this one over here, and we'll let you have a think about where that could be, but it looks around about just over half maybe, and just over -1.5, or just less than -1.5 I should say. So let's have a look at that one. So we've gone for -1.6 for that one and 0.6 for that one, and again that seems reasonable. Okay, and then of course you got the other one, which is this one. Well, again, I reckon it's just past halfway, so let's go for 0.6 and -1.6, so the other way around really. So 0.6 and -1.6. So that gives me the two solutions of it. All right. So because we're asked for the solutions, we have to write it slightly different than the coordinate. So we have to say x equals -1.6 and y equals 0.6. So that's the first coordinate effectively. Or, and then the second one, x equals 0.6 and y equals -1.6 over there. All right, so you've got two solutions to this, two ways of basically plotting the equations and finding the solutions. All right, so that's what you need to do. All right, I hope you've learned an awful lot. Obviously, there is a bunch of practice on maths-cloud, so maths-school.co.uk. So please have a look at the link at the bottom of the page, and please go on and give it a bit of practice. All right, and by all means revisit the video if you feel the need to further down the line. All right, thanks for listening.